Hi all, welcome you all to the next video on problems with 5 variable using K mapping. So now we'll look into one example of simplifying the Boolean expression of f of p, q, r, s, t, where we have been given a min term, that is 0, 2, 4, 7, 8, 10, 12, 16, 18, 20, 23, 24, 25, 26, 27, 28. So the moment we see the question, it is quite observant that I have been provided with 5 variables. But if suppose the variable is not been provided and it is you who have to guess, then we have to look into the symbolic expression that is been given, that is the min term, and look into that largest number. So the largest number is 28. So it is quite evident that 2 to the power 4 that has 16 cells may not be into this category. So we'll check out for 2 to the power 5. So when we move with 2 to the power 5, it is quite observant that 2 to the power 5 will lead to 32 cells. So with this clue, we could come to a conclusion that the given symbolic expression is of 5 variable. So now the question comes that how is this 32 cells could be constructed as a K map. So here 32 cells has to be broken up into 16 plus 16. So we can create a K map for 16 cell and another K map for the 16 cell. So this is how we land up with 16 cell and 16 cell, where if I am taking my two variable to be q, r and s and t, here also it is q, r and s and t, then the p is to be considered as this one block or K map. The first K map block could be considered as P is equal to 0, and the second K map block could be considered as P is equal to 1. So now we would go with designating our values 0, 0, 0, 1, 1, 1, 1, 0. Similarly, here it is 0, 0, 0, 1, 1, 1, 1, 0. Here it is 0, 0, 0, 1, 1, 1, 1, 0. So now we can also express it in terms of our literals or variables. Since it is a min term represents my SOP, and when it comes to my SOP, it is quite evident that my A takes the value 1 and my A complementary takes the value 0. So this could be written as S complementary T complementary. S complementary T, it is S T and it is S T complementary. So same goes out here, S complementary T complementary, S complementary T, S T, S T complementary. So here you will have the same Q complementary R complementary, Q complementary R, it is Q R, it is Q R complementary. So now we have to now check out that how are we going to designate this 32 cells for this K map that is being designed. So here let me just put up the designation starting from the first K map block as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this gives us our 16 cells, and we need to continue this count to our next second block with 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So this is how we have designated our cells. So now we will just look into the given problem, and from there we would be able to very well guess out that what basically is my filling of this K map is. Since it is a min term and SOP, my filling would be done with 1. So now it is 0. So my 1 will lie here, then comes 2, 1 will lie here, then comes 4, then comes 7, then comes 8, then comes 10, 12, 16, 18, 20, 23, 24, 25, 26, next comes 27, next comes 28. So now here we have marked our ones in our K map. So now how is the grouping to be done? So we have to just keep in mind few of the rules for the grouping under my 5 variable. So now we have to go with the grouping where I have to ensure that my grouping is being done as largest as possible, and the grouping is to be the power of 2, that is 2 to the power of 4, 2 to the power of 2, right? So but since we have the map given to us, we need to observe. So the first thing we need to do is just try to place my block 2 over my block 1 and check out if there is any similarity or is there any ones that are overlapping. So when I happen to place my block B2 on my block B1, I would see that this and this are stacked one above the other. In the same way, do you observe anything else being stacked? So you would observe that the stacking is being done for 1, 2, 3, 4. So as I have already said that once we go into our grouping, we have to be very conscious that we are grouping all the possibilities of the largest one. So here the grouping of 4, how it is possible, all those possibilities we can do. So next, if you just look into any other overlapping, we would observe that this and this is actually overlapping when the block B2 is stacked above the block B1. And finally, we would observe that all my ones are being grouped except for the one in block B2. And here we would observe that the grouping could be again done for 4 in this manner. So a grouping here can be done for a 4 again in this manner. So now what we have to do very consciously is to name the group and start naming the groups again. So if I look into my yellow grouping is a common grouping for both 1 and block 2. So if I name this as my group 1, then I just have to now look into this yellow group. This yellow group, if I just look into the rows, my rows, if I just try to observe my variant or my binary values, I would observe that none of my variables are repeated. So row wise, probably I have nothing to be represented, but if I just look into the column, then it is to a single column it is representing and there is nothing to compare. So it is S complementary T complementary. But one thing that has to be quite uh, understood, that in my block B1 my P is equal to 0, and in my block P2 my P is equal to 1. So when I look into the comparison of P, I don't see anything in common, and so I have nothing to include as the literates here. So now I look into my group G, the one with the green. So I name the group with the green to be nothing but my group 2. So when I stack my K2 block over my K1, then the four corners are being paired quadrant. So now when I just look into the row comparison, I would observe that the variables that are common for the first and the fourth one are complementary, that is row wise. And when I just look into my column, then it is 0 0 and 1 0. So what is there in common is T complementary. Next, if I happen to look into my red, that is a common grouping for both block 1 and K block 2, then it is nothing but, if I just look into the row, it is a single value, that is Q complementary R, and when I just take to the column, it is the single column, that is 1 comma R 1, that is ST. And what is left out now is nothing but your violet color group, which is purely belonging to my K map 2. So I will just look into that second K map, and there for that K map alone I would be naming my group 4. So here the comparison of P is only with that P is equal to 1, so that will exist, and the row is also to one row, that is 1 comma 0, so it is Q R dash. And if I happen to look column wise, then I would observe that all these four columns there is nothing to be compared in common, and so my group 4 is been named as PQR complementary. So now I could write my expression, that is my minimized expression, or the simplified form, as S complementary T complementary plus G2 R complementary T complementary plus Q complementary R S T plus P Q R complementary. So this is how we need to solve problems under 5 variable. So I hope you would have understood that how we are supposed to simplify a K map for 5 variable